To successfully run and trust your iOS app on a device, it's essential to understand how the Developer App Certificate plays a critical role. This certificate is a special file that's installed on your iOS device alongside your app, allowing it to be signed and trusted by the device. In this lesson, we're going to delve into the details of app certificates, device provisioning, and the steps to run your iOS app on a physical device. So far, we've learned about setting up Xcode, Apple's IDE for iOS app development, and how to create our first app. We've explored the user interface, added a label and button, and learned how to connect them to our code for interactivity. We also navigated between view controllers and passed data between them, which laid down a strong foundation for app development. Just a quick reminder, remember to test regularly and keep learning as you continue your journey in creating amazing applications. Now, let's cover how to run your app on an iOS device while making sure it's trusted and set up correctly. Let's start with how to obtain a Developer App Certificate. This process typically begins on the Apple developer website, where you'll need to enable your developer account. Just to get started. Once you're logged in, you'll want to navigate to the Certificates, Identifiers, and Profiles section. Here, you need to create a new certificate by selecting the appropriate type based on your app's needs. The two common types are development and production certificates. Now, for our purposes, we'll focus on the development certificate. To create this certificate, you'll need to generate a certificate signing request, or CSR, using Keychain Access on your Mac. So, open Keychain Access, and from the top menu, select Certificate Assistant. Then choose Request a Certificate from a Certificate Authority. You'll fill in your email and name, select Save to Disk, and then click Continue. This action will give you the CSR file that you'll upload to the Apple Developer Portal. And that's it, you've got your CSR. You're well on your way to setting up your Developer App Certificate. The accompanying pie chart titled Importance of Certificate Types and Trust in iOS App Development displays 4 categories and their relative importance. Development Certificate at 40%, Production Certificate at 30%, Provisional Profile at 20%, and Device Trust at 10%. Now, if we take a closer look at this chart, it's clear that the development certificate carries the largest single share at 40%, indicating that it's the most emphasized element in day-to-day development workflows. Following that, we have production certificates at 30%, and when we add those two together, we account for a whopping 70% of the depicted importance. This really highlights that certificate management, particularly for development and production, absolutely dominates the overall focus. Now, provisional profiles, well, they represent a meaningful but smaller portion at 20%. This signals that device provisioning and profiles are important for enabling those device-specific installs. Lastly, we see device trust as the smallest slice at 10%, which shows that while trusting the developer identity on the device is necessary, it occupies a smaller fraction of the overall certificate and profile concerns. These proportions suggest that we should prioritize certificate creation and correct signing first, then move on to provisional profiles, and finally ensure that device trust steps are completed. Now, let's take a look at how to determine whether automatic signing is enabled in Xcode. So the code snippet that we're working with begins with a conditional statement that checks the value of the auto-signing enabled variable. If this variable is set to true, the application will print a message saying automatic signing is enabled. This feature really simplifies the signing process because it allows Xcode to manage the signing identity and provisioning profiles for your app automatically, which is particularly beneficial for new developers who might find managing certificates and provisioning profiles a bit daunting. Now, on the flip side, if auto-signing enabled is false, the output will indicate that manual signing will be required. This usually happens when developers prefer to take the reins, handling the signing processes themselves for greater control over which certificates and provisioning profiles are used. Understanding this code is essential for developers, so they can be aware of their app's signing state before running it on a physical device. This knowledge ultimately guides them on the necessary steps to ensure the app is properly signed and, trustable by the device. Getting this right can really help prevent potential deployment issues, making it a core component of the app development workflow.
Once your device is connected, you may need to trust your developer certificate on the device. To do this, head over to Settings on your iOS device, navigate to General, and scroll down until you see Device Management. Find your developer app certificate there. Select it, then tap Trust Your Developer Name. This step is crucial because it establishes the trustworthiness of your app, allowing it to run smoothly on your device without any hiccups. All right, with everything properly set up, you're ready to run your app. Just choose your physical device from the list of targets in Xcode and press that Run button. Xcode will compile the app, install it on your device, and launch it. And voila, you should see your app pop up on your home screen, ready to be used. For those of you who are curious about managing different types of builds, it is indeed possible to designate a debug or release build. In the project settings, under Build Settings, you can configure various build configurations. This is where you can specify which ones correlate with development and production builds. Pretty neat, right?
Now, let's take a look at how we can check for network availability within your app, which is crucial for ensuring smooth functionality, especially if it relies on internet access. So to start, the code begins with importing the necessary connectivity manager from Android's networking library. This manager serves as the gateway for accessing information about network connections. Next, we define a function called isNetworkAvailable, which takes a connectivity manager instance as a parameter. Within this function, we retrieve the current Octave network information using connectivitymanager.octavenetworkinfo. Now, this property provides details about the network connection currently in use, if any. To determine if the device has an active internet connection, we're going to check if network info is not null and if the device is connected. If both conditions are met, the function returns true, indicating that network access is available. This simple yet effective method enables developers to incorporate connectivity checks into their apps, allowing for better handling of potential network issues, sounding reassuring, and enhancing user experience by adapting to the current connectivity state. The process of running and trusting your app comes with its own set of potential hurdles. For instance, errors can occur if the provisioning profile doesn't match your app's bundle identifier. So always double-check that the bundle identifier matches the one specified in your Apple developer account. Updating your identifiers takes only a few clicks in the Certificates, Identifiers, and Profiles section of the developer portal, and it's super easy. Now, debugging can also add another layer of complexity. Thankfully, Xcode provides a robust debugging toolset that allows you to set breakpoints and view the console output. Using the debugger helps you inspect app behavior in real time. It's a fantastic way to figure out where things may be going wrong and to ensure that your app is functioning as intended. Enhancing user experience is another critical aspect while testing your app, so pay attention to how your app responds to various gestures and inputs. Regular testing on different devices can reveal issues related to different screen sizes and orientations that you might not encounter on your simulator, so don't skip this crucial step. Finally, after successfully running and testing your app on your iOS device, remember to distribute it effectively, especially if you plan to share it with others. One great way to do this is by using TestFlight for beta testing. This platform makes it super easy for your peers or clients to install the app and give you valuable feedback on its usability and performance. Now, creating an effective beta testing strategy is crucial. Make sure you provide clear instructions alongside the app link, detailing exactly how your testers can install the app and report any issues they encounter. And remember, always listen to feedback during this phase, as it can really highlight areas for improvement. By now, you should have a clear understanding of how to run and trust your iOS app on a device, along with the steps involved in setting everything up. The key components include working with developer ops certificates, provisioning profiles, and efficient testing practices. Each of these plays a vital role in ensuring that your app runs smoothly on physical devices, ultimately paving the way for successful app deployment in the real world. In summary, we've gone through the essential steps for iOS development, which include obtaining a developer app certificate, setting up provisioning profiles in Xcode, and the crucial steps for running your app on an iOS device. We also dived into debugging practices and explored how to ensure a smooth user experience by thorough testing. Now, I know at first glance, the world of iOS development can seem a bit daunting, but trust me, with a little practice and a sprinkle of patience, you'll really start to master the art of creating and delivering amazing applications to users everywhere. So, keep pushing those boundaries, and remember, the most important part is to enjoy the journey of development.